To the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the database design concepts, and the same chapter, that is chapter number 11, that is indexing and hashing. In the last class we have talked about the some information about the B plus tree and how to make the update on the B plus tree. So let's start with the previous class session, then move to today's topic, that is how to recover files, or what are the file organization that is used in the B plus trees. So first topic that we have discussed in the last class is the B plus tree, or there is will be updates on the B plus tree, that is how to make the updates, how the updates will be available in the B plus tree. So let's start the session with the updates of the B plus tree. So there will be updation that is available on the B plus tree. So when the data is recorded or inserted into or deleted from a relation, indices on the relation must be updated correspondingly. So whenever any decode, when any data or any record is inserted or deleted from the relation from the record, then automatically the indices on the relation must be uploaded automatically or correspondingly. Whenever we insert the data, whenever we delete the data, that are more complicated than the lookup table, since it may be necessary to split a node that becomes too large as a result of the intersection of the coalesced nodes. So if a node becomes too large, so the node is divided into multiple pairs, that is divided into multiple forms to make the data available in the two available content. Then we have talked about the insertion and the deletion, that is how to insert the data and how to delete the data. This is the example of the insertion and the deletion that we have discussed. This is the insertion, that is how to insert the multiple words that is used in the database concepts. This is the example of the insertion. This is the split of the lead node on the insertion of the addons. This is the insertion, that is how to insert the data. Then we have also talked about the deletion of the data, that is how to delete the data. This is the example of deletion of the Srinivasan from the B plus tree. This is the deletion part. This is the non-unique search key, that is how to find the non-unique search key that is available in the deleted data, that is the non-unique search keys. So if a relation have multiple keys, the relation have multiple data that is available that contains multiple index keys or index attribute that contains various non-unique search keys. This is a program for the non-unique search keys. Then we have talked about the complexity of the B plus tree update. That is, what is the complexity of on the B plus tree update that is available in the data. That is the complexity of the B plus tree update. So there is a complexity that is available, that is log n by 2n. Then we have talked about the B plus tree extension. That is, what are the various extensions that is available in the B plus tree. Then we also talked about the B plus tree extension, that is what are the various extensions that is available in the B plus tree. And this we have talked about the first of all the B plus tree file organization, that is what are the various organizations that is available in the B plus tree and what are the various contents that is used in the B plus tree. That is the first topic is the B plus tree file organization, that is how to organize the file in a various nodes with the various dependencies. We can say the various leaf node, various non-leaf node. So this says one of the major drawback that is available in the index sequence file is that automatically the performance will be degraded, or it will be going down whenever the file grows. So whenever the size of the file is grown, so automatically the performance is degraded. So with the growth, an increasing percentage of index entry and an actual records become out of order and are stored in the overflow blocks. We solve the degradation of index lookup by using the B plus tree indices on the file. So whenever we use the B plus indices or B plus tree indices, that is used for the degradation of the files. We can use the B plus tree structure not only as an index but also as an organization or organizer for records in a file. So we use the organizer for the files in a record that is used to update the data. In B plus tree file organization, the leaf nodes of the tree stores records instead of storing the pointers. So whenever we use the file organization, it stores the pointers. It stores the records instead of storing the pointer, because in index file we store the pointers that is used for pointing, that is used for refers to the indices. But in this we have to store the records instead of storing the pointer. That is one of the main difference between the index sequential and the B plus tree file organization. This is one of the advantages that is used or that makes the insertion and deletion very easily. Then whenever we delete the data, that is the main concept. This is the main concept that is used to delete the data. B plus tree file organizations can also be used to store large objects such as SQL, curves or clubs and the blocks, which may be larger than the disk file as many as multiple gigabytes. Next is the secondary indices and the record relocation. That is, what are the secondary indices and the record relocation to make the data available, to make the data or records that have been updated. So relocation of the records because of the leaf node split then did not require any updates on any such secondary index. So if there is any relocation of the records because of the leaf node, that splits the records into various parts, into various, we can say, the secondary index files. However, locating a record using the secondary index now requires two steps. So there are two steps whenever we find the records in a index file. First of all, we find the index file to set the primary key for finding the search key values. Then use that primary key to find the corresponding records. It means first of all find the search key value for the secondary records, then use the primary index to find the corresponding record that is made available for such data or such records. Next is the indexing strings, that is how to use the index files or how to use the indices with the concept with the concept that is the strings. Now the main problem is that strings can be long. It leads to the low fan out and the corresponding increased tree height. So whenever we use the string, the height of the tree is increased. That is the main point, that is the main problem, that is the main issue that is used with the index or index strings. So with variable length search keys, different nodes can have different fan outs even when they are if they are full. So the fan outs of the nodes can be increased by using the concept of the prefix compression. So whenever we increase or whenever we increase the technique, whenever we use the technique that is used by using the technique that is known as the prefix compression. Then next is the bulk loading of the B plus tree indices. That is how to load the B plus tree indices in a bulk. That is a bulk loading of B plus tree indices. So as we saw earlier, insertion of a record in B plus tree requires a number of input-output operations that in the worst case is proportional to the height of the tree, which is usually fairly small, that is typically 5 or less or even for the large relations. Now consider the case where a B plus tree is being built on a large relation. So this is the case where the B plus tree is built on a relation that is larger than the main memory, that is used to bulk the data, that is used to store the data. Then next is the B tree index files, that is very similar to the B plus tree index files. The main difference is that in a B plus tree there is a duplication record that can be, we can say, the delete the records of the duplicate records. So it gives the only the unique record that is available in the database. Next is the flash memory, that is structured as a blocks in which the data resides on the disk. So flash memory is in which the data is resides on the disk that is made available for the dependent data. A natural question is how would this change affect the index structure? If I use the flash memory, how it will be changed to the new structure? So flash memory storage is structured book or is structured as a block. So flash memory is used as a blocks and the B plus tree index structure can be used for the flash memory storage. So we use the flash memory storage for the data structure. The main drawback or the only drawback is that it does not permit the in-place updates to data at the physical level. That is, we cannot update the data on the physical level to make them reliable or to make them usable. Next is the multiple key access, that is today's topic, that is how to access the multiple keys together. If not more than or more than one keys are accessed together, that is a multiple keys access. So until now we have used or we have assumed implicitly that only one index on one attribute is used to process a query on a relation. So now till now we have focused on only one index on the one attribute that is used to process a query on a relation. But there are certain type of queries also that is more advantageous to use the multiple indices if they exist, or use an index file on a multi-attribute search key. So we are not using the only the one indices, but we are using the more than one indices to sort the data to, or we can say the as an attribute that is used to update the data. Now, using the multiple single key indices, that is how to use the multiple single key indices. So assume that the instructor files have two indices, one for the department name, one for the salary. So the instructor files have two indices, that is the one is the department name, one is the salary. Now consider the following query. Find all the instructors in the finance department with salary is equals to 80,000. So this is the question, that is find all the instructors in the finance department whose salary is equals to the 80,000. So the criteria is given, that is we have to find the instructor's name, we have to find the instructors whose salary is greater than or yeah, whose salary is equals to 80,000. So it is using the multiple keys, that is the department name and the salary, because both the conditions are satisfied, that is the department is finance and the salary is equals to the 80,000. So how we can write the query, that is select ID from the table instructor where the department name equals to finance and the salary equals to 80,000. So there are three strategies that is also possible for processing this query. So first one is that use the index on the department name to find all the records pertaining to the finance department. So there are three possible queries that is available with this query, or there are three possible technique that is used to process the query. So first one says either use the index on the department name to find all the records pertaining to the finance department. Examine each such record to see whether salary equals to 80,000. So examine the index on the department table, or put the index on the department table for to find all the records pertaining to the finance department, and examine each such record to see whether salary is equals to 80,000. Or second possibility is that use the index on the salary key to find the records pertaining to the instructor with salary is equal to 80,000. Means at any stage we have to put the query, we have to put the, we can say, the index that is available either on the one of the attribute that is available, that is the department attribute, department name, salary, finance, and anything that is used for the department table. Examine each such records to see whether the department name is finance or. Then third point says use the index on the department name to find the pointers to all the records pertaining to the finance department. So either we can use the department name, either we can use the salary, either we can use the index on the department name to find the pointers of the records pertaining to the finance department. Also use the index on the salary to find pointers to all the records pertaining to the instructors with a salary of rupees 80,000. Take the intersection of the two sets of column that is made available, that have a salary that is greater than 80,000. Those pointers that are in the intersection point to the records pertaining to the instructors or instructors of the finance department with salaries equals to the 80,000. Now the third strategy is the only one of three that take advantage of the existing or the existence of the multiple keys. So that is the last one is more better. That is to get, or that is the main advantage of existence of the multiple indices, because one indices is used for the department name and one indices is used for the salary. Now however, even this strategy may be a poor choice if the following hold. So these are the main, we can say, the drawbacks of this choice. So what is the strategy that is used, or how this technique strategy must be fail? First of all, if there are many records pertaining to the finance department, if there are n number of record that is pertaining, that is reflecting to the finance department, then also the strategy is not work. Last one, that is assigning the pointers to all the records pertaining to the finance department. Then next is there are many records pertaining to the instructors with the salary is equals to the 80,000. That means there are multiple data that is available. That is also we can say the poor choice whenever we use the department name and the salary to find the records of the finance department. Next, there are few people or the few records pertaining to both the finance and the instructor with the salary is equals to the 80,000. So in these conditions hold, or if these conditions hold, we must scan a large number of pointers to find the small results. An index structure, also known as the bitmap index, can in some cases greatly speed up the performance or intersection operation used in the third strategy. Bitmap indices are outlined in course 90.1. Now, what are the various indices that is available on the multiple keys? The next is the indices on the multiple keys. That is how to find the index on the multiple keys. So one of the best technology, one of the best approach that is used for the indices on the multiple keys, that is used to create and use an index on a composite search key, that is a department name salary. That is a search key consisted of the department name concatenated with the instructor salary. So we can use an ordered tree, that is a B plus tree index on the above composite search key to answer efficiently queries of the form. This is one of the example, that is a attribute that is used. So query such equality condition on the first attribute, that is a department name, and the range on the second attribute of the search key, that is a salary, can also be handled efficiently because they correspond to the range query on a such attribute. Then select ID from department or from instructor where the department name equals to finance and the salary is greater than or less than 80,000. We can even use an ordered index on the search key, that is the department name and the salary, to answer the following query on only one attribute efficiently. So we can also use the query on the one attribute. We can also put the queries on the multiple attributes. So whenever we use the multiple keys for the query that is used, so whenever that is known as the multiple keys on the indices. Then next is the covering indices, that is the indices that stores the value of some attributes other than the search key attributes along with the pointers to the record. So we can what is the covering indices? That is the indices that stores the value of some attributes other than the search key attribute that is available, that stores the value along with the pointer. So in this, the indices or the attributes are stored along with the pointer that point to the next location, that is also used as the address of the records. Storing extra attribute values is useful with secondary indices. So whenever we store extra attribute value, that is stored with the secondary indices, since they allows us to answer some queries just like the index without even looking up the value, without even looking up the actual records. That is a covering indices that stores the value of some attributes. Then for example, suppose that we have a non-clustering index on the ID attributes of the instructor relation. So if we have a non-clustering index that is available on the ID attribute of the instructor relation, if we store the value of the salary attribute along with the record pointer, we can answer the query that requires the salary without accessing the instructor record. That means whenever we use the non-clustering index, on the ID attribute of the instructor relation, we store the value of the salary along with the record pointer. Then we answer the query with the help of the instructor record. Now, next concept is static hashing. That is what is the meaning of static hashing, or we are now forward to the next part, that is hashing. So we have covered this chapter, that is chapter name is indexing and hashing, and we have covered with the first topic, that is the indexing, that is used to search the records on the basis of the index. Now next is the hashing, that is static hashing. So one disadvantage of sequential file organization is that we must access an index structure to locate the data, or must use binary search, and that results in more input-output operation. So one of the disadvantages of sequential file structure is that we must access an index structure to locate the data. So there must be an index structure, there must be a requirement of the index or the value that is used to locate the data, or we must use the binary search, and that results in a more input-output operations. File organizations based on the technique of hashing allows us to avoid accessing an index structure. So there is a limitation, there is a fact that is used, so we can avoid the limitation, we can avoid the data, we can access we can avoid accessing an index structure when we use the technique of the hashing. So hashing is a technique that allows us to avoid the accessing an index structure. Hashing also provides a way of constructing indices. So hashing is also a method or the way to find out the constructing indices. We study file organizations and indices based on the hashing in the following sections. In our description of hashing, we shall use the term bucket to denote a unit of storage that can store one or more records. There will be a bucket, or there will be so that will be use the term bucket to denote a data of the or the unit of the storage that can store one or more records. So that will be used to store one or more record, that is a bucket. So bucket is typically a disk block but could be chosen to be smaller or larger than the disk block. So this is nothing but the disk block, that is a bucket, that is a unit of storage that can store one or more records. That is typically a disk block but could be chosen to the smaller or the larger than the disk blocks. Formally, let K denote the set of the all search key values and let B denote the set of all bucket addresses. So K is the value, or we can say the K denotes the all search key values that is available, and the B denotes the set of all bucket addresses. So one is the search key value, one is the bucket addresses. And hash function, that is a H, is a function from K to B. So there is a function that is used, so that function is known as the function from the K to B. So there's a hash function that is used, that is available from the K to B, that is from the index file or from the search index to the set of the bucket addresses. Now let H denotes a hash function. So H means a hash function that is used to store the indices, or that is used to avoid accessing the index file and constructing the new indices, or we can say that hashing is a technique to find out the search technique. So to insert a so hash function is a function from K to B. So to insert a record with the search key Ki, we must compute the HKI. So whenever I want to insert any data, whenever I want to get any data, we can use the bucket, we can use the data, we can use the hash function from the K to B, we can use the HKI, that means inserting the data which gives the address of the bucket of that record in which we have to store the insert the data. So this is HKI, means inserting the data with the help of the bucket addresses. Assume for now that there is a space in the bucket to store the record. So now assumption is that there is also again the more space that is available to store the record. Then the record is stored in that bucket. To perform a lookup on the search key values K, we simply compute HKI. So if I want to perform a lookup on the search key, that is what the value looks like, we will simply compute the concept, that is a HKI, then search is the bucket with that address. Suppose that two search keys, that is the K5 and the K7, had the same hash value. So suppose there will be a same hash value that is used, so we can use the HK5 equals to HK7. So if we perform a lookup on K5, the bucket HK5 contains a record with the search key values K5 and the record with the search key values K7. So we will record the values, we will search the values, that is the K5 and the K7. Therefore, we have to check the search key values of every record in the bucket to verify that the record is the one that we want. So that means if I want to search anything, first of all go for the H5 and the H7, for example K5 and the K7, then use the search key values in the bucket to verify that the record is the one that we want to search. Deletion is equally straightforward. So deletion is almost the straightforward. There is, if the search key of the record is to be deleted, we simply use the HKI, then the corresponding bucket for that record, and delete the record from the bucket. So simply if I want to delete, simply search the bucket in which the data will be stored, then simply delete the bucket, delete the record from the bucket. Now hashing can be used for the two different concepts. So hashing can be used for the concepts of the two types. First of all, in a hash file organization, we obtain the address of the disk blocks containing a desired record directly by computing a function on the search key values of the record. So the first purpose is that we can use the hash file organization, that is every file that contains the hashing function that contains the hash table must be organized. Then we must obtain the address that is used for the disk block that contains a desired information for that blockage. Next is in a hash index organization. So one is a hash file organization, one is a hash index organization, we reorganize the search keys with their associated pointers into a hash file structure. So we organize the search key that is also used with the pointer that is used in the hash file structure. So one is the hash file organization, one is the hash index organization. Next is the hash function, that is how to use the hash functions. So the worst possible hash function map all the search key value to the same bucket. So the worst means the very wrong possible maps or very wrong possible hash function includes the mapping of all the search keys values to the same bucket. So sometimes the same value bucket will be searched again and again with the same index value. That is very wrong hash function that is used. Such a function is undesirable because all the records have to be kept in the same bucket. So such functions are not working well because every record must be updated in the same bucket in which it will be used. A lookup has to examine every such record to find the one desired. An ideal hash function distributes the stored keys uniformly across all the buckets. So whenever we use the appropriate hash function, that will give the data equally to the different buckets, so that every bucket has the same number of records and there is no partiality, there is no every content that is available for the buckets. Since we do not know at design time precisely which search key values will be stored in the file, we want to choose a hash function that assigns search key values to the bucket in such a manner that the distribution has these qualities. So we can distribute the files, we can distribute the search key values in the buckets in such a manner it will qualify the following entries, it will qualify the following values. First qualification or the first criteria quality is that the distribution is uniform. That is, the distribution is uniform, that is, in every bucket there must be a same record that will be entered, there will be a same search key or same number of search key that will be entered in the record. That is, the distribution is uniform. Then the distribution is random, that is, we can randomly pick any bucket and store the search key, not first of all one bucket, then another bucket, another bucket. No, that is not the criteria, but we can simply distribute the search key value in the bucket and the random. This is one of the example. These are the various buckets that is used. So this is the hash organization of the instructor files. There is a bucket 0, bucket 1, 1 record, 2 records, 3. Then this is the next record that is available. Then bucket 5, 6 and 7. The next is handling of the bucket overflow. That is how to handle the bucket overflow. So the next is the handling of the bucket overflow. So if the bucket overflows, that means there is no container, there is no space in the bucket, then how to manage or how to handle the bucket overflow. So far we have assumed that when a record is inserted, the bucket to which it is mapped has a space to store the record. So till now we discuss, or till now we assume that the whenever we store the data, whenever we store the records in the bucket must have enough space to handle the data that is available in the bucket. But if the bucket does not have enough space, a bucket overflow is said to occur. So if the bucket is not available or the space is not available, then the bucket has to be, or is said to be, or there will be a bucket overflow that is said to occur. So bucket overflow can be occur due to the following reason. There will be an insufficient bucket, that is the number of bucket that is required is less than the what is required, or the number of bucket that is used is less than the required buckets. Then skew, some buckets are assigned more records than other, so a bucket may overflow even when other buckets still have space. So there will be sometime it depends on the bucket to bucket. So if there is any overflow that is used, so that bucket will store the data, that bucket will give the data, but it depends on the bucket to bucket. That is a skew. What are the two reasons? First of all, multiple records may have the same search key. So whenever some bucket does not show the space, that means there will be a skew in the data, that is known as the bucket skew. And that, first of all, one of the reason is that multiple records may have the same search key in the skew, and the chosen hash function may result in uniform distribution of search records. So these are the two reasons why there is a data that is, or why there is a bucket, or why there is a data that is available in the form of the skew. Because can be occur for the reasons. What are the two reasons? First of all, the multiple records may have the same search key, and the chosen hash function may result in non-uniform distribution of the search keys. Despite allocation of the few more buckets than required, bucket overflow can still occur. We handle the bucket overflow by using the overflow bucket. So we handle this concept by using the overflow buckets. So if the record is entered or inserted into the bucket B and B is already full, the system provides an overflow bucket for the B. So system provides an overflow bucket for the B. So there will be a concept, there will be a two words that is used for the overflow buckets, that is the overflow bucket. In the same way, if it is available for the B, that means overflow bucket for the B, and inserts the record into the overflow bucket. Now, if the overflow bucket is also full, the system provides another overflow bucket, and so on. So automatically it will use that overflow bucket for B, overflow bucket for C, overflow bucket for D. Automatically it going till it is required. All the overflow buckets of a given buckets are chained together in the linked list. And the overflow handling using such a link is known as the overflow chaining. This is the overflow chaining in a hash structure. This is the 1124. That is the bucket 0, 1, 2, 3. This is the overflow bucket for the bucket 1. This is going for this one, going for this one, and so on. Now, then the next paragraph says we must change the lookup algorithm slightly to handle overflow chaining. So whenever we use the buffer overflow, whenever we use the lookup algorithm, that will use to handle the overflow chaining. As before, the system also uses the hash function on the search key. So it uses the hash function whenever it is used to on the search key to identify a bucket, that is B. The system examines all the buckets in the B to see whatever they match the search key as before. The form of hash structure that we have just described, that is changing or checking the data, that is also used, that is known as the closed hashing. And under an alternative approach, we can also use the open hashing, that is the close and the open hashing. So one policy is to use the next bucket. So there are two types of approaches that is used. That is, one is known as the closed hashing, one is known as the open hashing. That is the alternative approach that is used. The set of buckets is fixed and there are no overflow chains. Instead, if a bucket is full and the system inserts records in other buckets in the initial set of buckets B. One policy to use the next bucket that has space. This policy is known as linear probing. That is one of the policies that is used to use the next bucket that has a space that is used, or that policy is known as the linear probing. That is pass the data or record the data to the next bucket that has a data, that is known as a linear probing. Other policies such as computing further hash functions are also used. Open hashing have been used to construct symbols table for the compilers and the assemblers, but closed hashing is preferable for the database system. The reason is that deletion under the open hashing is the troublesome. This is the main reason. And the drawback to the form of hashing that we describe is that we must choose the hash function that what we implement in the system, and it cannot be changed easily thereafter. That is, we cannot change the data automatically if it is used. So it is automatically changed, or it is we have to change the data and we can implement the system, and cannot be changed easily thereafter if the file being the index being the strong or the grows or the shrink. So as the file grows, performance suffers. We study later in section 11.7 how the number of buckets and the hash function can be changed dynamically. This is the hash index on the search key ID with this one. This is the next concept. So next is the hash indices. Now we are using the index value. Now the next concept is using the index value like we have done in the sequential file, but now we are using the indexes or indices on the hash values or the hash function. So hashing can be done not only for the organization but also for the index structure. So the hashing can be done not only for the file organization but also for the index structure creation. A hash file function or the hash index organizes the search keys with their associated pointers into a hash file structure that is also used. We construct a index file, or we construct a hash index as follows. We apply a hash function on a search key to identify a bucket. So first of all, it is used to identify a bucket and store the key and its associated data or pointer in the bucket. Figure 11.25 shows a secondary hash index on the instructor file. This is the bucket 0 that stores the first data, or we can use the ID of the first instructor. Then there is a bucket 2 that stores two data, that is 45564765543. Then bucket 3, this refers to the first record, this refers to the third record, and this refers to this record. In the same way, there are total 7 buckets that is available. These are the data, that is how to use the hash function, or what is the main criteria to use the hash function that is used to generate the reports, that is using the hash function. So the hash index organizing the search key that is used for the search key. The hash function in the figure computes the sum of the digits of the ID modulo 8. The hash index at 8 buckets. So this has a 8 bucket that have two values, that have a two stock that is used to store the data that is done in the organizations. That is, realistic indices would of course have much larger than the bucket size. One of the buckets per size, or one of the buckets has 3 keys that is mapped to it. So one of the bucket has 3 keys that is mapped to it. So it has an overflow bucket. In the example, ID is a primary key for the instructor, so each such key have to be associated with the pointers. Now next is the dynamic hashing. So next concept is related to the hashing, but this is the concept of the dynamic hashing. That is, hash values, or the index hash values must be changed accordingly. That is known as the dynamic hashing. So as we have seen, the need to fix the set B of the bucket address presents a file, or presents a data in the file that is used to ignore the data that is used to store the data. So the need to fix the bucket address presents a serious problem with the static hashing technique of the previous section. Most database grows larger over time. So every database grows in a larger way, or larger over time. If we are to use static hashing for such a database, we have 3 classes of options. So if we are using only the static classes for the growing database, there are 3 difficulties, or there are 3 challenges that is available. The first one is that choose a hash function based on the current file size. So choose the hash function that is used for the current file size. This option will result in the performance degradation as the database grows. So whenever automatically the database grows, the performance degraded if we use the static hashing. Then choose a hash function based on the anticipated file of the or size of the file at some time in the future. Periodically recognize or reorganize the hash structure in response to the file organization. Further, it is necessary to forbid the access to a file during reorganization. Several dynamic hashing techniques also allows the hash function to be modified dynamically to accommodate the growth or shrinkage of the database. So whenever we use the dynamic hash function, whenever we use the dynamic hash technique, that allows the hash function to be modified dynamically. So the hash function must be used dynamically to accommodate the growth or shrinkage of the database. In this section, we describe one form of dynamic hashing that is known as the extendable hashing. That is the extendable hashing. Now, what is the data structure behind or what is the meaning of the extendable hashing? So extendable hashing copies with changes, or copes with changes in the database size by splitting and coalescing buckets. As the database grows, it shrinks. So whenever we use the data structure, whenever we use the extendable hashing, that copies or that copes with the changes, as the database grows, this also grows. As a result, space efficiency is retained. Moreover, since the reorganization is performed on any one block at a time, the resulting performance overhead is acceptably lower. So whenever you use the space efficiency, whenever you use a reorganization that is performed in the one bucket at a time, the resulting performance overhead is acceptably slow. With extendable hashing, we can choose a hash function that is h with the desirable properties of the uniformity and the randomness. So whenever we use the extendable hashing, that is used to choose a hash function h with the desired properties of the uniformity and the randomness. However, this hash function generates value over a relatively large range, namely 6 or the b bit in binary integers. A typical value of b is 32. This is a general extendable hash structure. Then the next is the queries and the updates. Now we'll see how to perform the lookup, insertion and the deletion on an extendable hash structure. That is the queries and the updates. So to locate the bucket containing such key values, that is a ki, the system takes the first ki, that is the high order bits of the h, looks at the corresponding table entry for the bit function or the fit string and follows the bucket pointer in the table entry and use a bucket table or bucket pointer in the table entry. To insert a record with the such key values ki, the system follows the same procedure as we do in the ending up in the bucket. There are three conditions that is used if the I is equals to the j, that is the two nodes that is to be deleted or that is to be inserted, that is the search key that is to be inserted, and that is known as the I and the j. That is only one entry in the bucket stole table points to the bucket j. That is I is also the entry and the bucket name is the bucket j. The first is if I is equal to ij, then I is greater than ij. That is the three forms or two forms the extendable file structure. This is also the hashing, dynamic hashing with the 6 instructions with the 7 instructions or instructor that is used to adding on. So this is the example or the hash function for the department name. This is the department, this is in the binary terms. The system then reattempt the insert. In the likely unlikely case that it again fails, it applies one or two cases, that is a I is equals to j or the j is greater than I as appropriate. Note that in both the cases the system needs to recompute the hash function on only the records in the bucket j. So there is a demand, there is a concept that is used to recompute the hash function that is used for finding the records in the bucket j. Now if I want to delete a record with the search key value ki, the system follows the same procedure as we do, ending up in the sum bucket say j. It removes both the search key from the bucket and record from the file. So it also removes the bucket, it also removes the search key, it also removes the record from the file. The bucket 2 is removed if it becomes empty. Note that at this point several buckets can be coalesced and the size of the bucket address table can be cut in the half. So to illustrate the operation of the instruction or insertion, we use the instructor file and assumes that the search key is department name. That is, assume that the search key that is available is the department name with the 32-bit hash values as appear in the figure 11.7 or 11.27. Assume that initially the file is empty, that is available over here. This is the example that is used for the department name. This is the blank database. Then hash structure after the three insertions. So we have included or we are holding the three instructors. If we insert the record this one, the bucket address contains a pointer to the one bucket and the system inserts the record. Next we insert the record, that is the next part, that is a 12121 WU finance 90,000. System also places the records in the one bucket of our structure. When we attempt to insert the next record, that is a 15 any record, we find that the bucket is full. Since I equals to I0, we need to increase the number of bits and we must use the hash values. We now use 1 bit assuming 2 power 1 equals to 2 buckets. The increase in the number of the bits necessitates doubling the size of the bucket header that is divided into two entries. Next, if you want to insert 222 in string physics 95,000, since the first block of the H, that is the physics, is the 1. Once again, we find the bucket full, that is I equals to ij. This is one of the example. So this is the, we can say the one of the example. This is 1 is divided into 2 parts, that is the data will be inserted, 3 data will be inserted, that is 15151, that is a 101025. Now we insert the 222, that is this one. We insert the 222, that is this one. Now this is the hash structure. After the 6 insertion, 6 data will be recorded up. This increase in the number of bits necessitates doubling the size of the bucket address table to 4 entries as given in the figure 11.30. This is 11.30. This is the 4 figures, 5 figure that is available in the bucket function. This is the hash structure after the 11 insertions. This is the instructor table or the extendable hash table for the instructor table. Now next is the static hashing versus dynamic hashing. That is, what is the main difference between the static hashing and the dynamic hashing. So we now examine the advantages and disadvantages of extensible hashing compared with the static hashing. The main advantage of extendable hashing is that performance does not degrade as the file grows. One of the main advantages of the extendable hashing, that is the dynamic hashing, is that performance does not degrade if the file of the database grows. So although the bucket address table incurs additional overcode, it contains one pointer for each search key for the current file structure. Now what is the disadvantage of the that is the dynamic hashing, that is extendable hashing, is that lookup values involves an additional level of indirection. That is the lookup value that is available are additional level of indirection, that is they are not good as compared to the direction values. The bibliographically notes also provide references to another form of dynamic hashing, that is known as a linear hashing. Thus, extensible hashing appears to be a highly attractive technique, provided that we are willing to accept the added complexity involved in the implementation or in its implementation. And that is a linear hashing that avoids the extra level of indirection associated with the extensible hashing at the possible cost of the overflow buckets. Now next is the comparison of ordered hashing and indexing. That is, there's a comparison between the index and the hashing. That is, I think, the last chapter or last topic of this book. So we have seen the order indexing scheme, several hashing schemes. Now we can organize files of records as ordered files by using the index or the B plus tree organizations. In the alternate, we can organize a file by using the hashing. So we can either organize a file by using the indexing, either we can organize a file by using the hashing. Finally, we can organize a file them as a heap files where the records are not entered in any particular way. Every scheme that is available, indexing and the hashing, both are the very good schemes, and each scheme has some advantages in different situations. A database system implementer could provide many schemes. So if there is a database implementer that is available that provides multiple schemes in the database to use to the larger databases. However, such an approach requires the implementer to write more codes, adding more data to the cost of system and space that the system occupies. To take a choice of the file organization and the indexing scheme for relation, what are the various issues that is used? First issue is that, is the cost of periodic reorganization of the index or hash organization acceptable? If we are spending much of cost on the hashing and the indexing, that is acceptable or not? What is the relative frequency of insertion and the deletion? That is, what is the main speed, what is the frequency, that is the bandwidth of the insertion and the deletion. It is desirable to promote or optimize average access time at the response of increasing the worst case access time. So it is desirable to store the values or optimize average access time. Then what type of queries are user likely to process? Now next is the bitmap indices. That is how to use the bitmap indices. So that's all for today's session. I'm not going to start this topic right now because there is no student right now. So in the next class, that is in the Monday's class, that is a day after tomorrow, that is on the 3rd of August class. 3rd of August there is only class that is from 4 to 6 as per the IST. There is no change in the time as per the schedule. It is going on, that is from 4 to the 6 as per the IST. So if there is any doubts, any confusions in this topic, in this chapter, any topic, any module, then you can ask the doubts from me. Okay, all right. So thanks a lot everyone for listening me. Bye bye everyone.